Okay, welcome. So I'm going to talk through a little bit about how I actually created this simulation for the interested viewer that wants to know a little bit more behind how they might create such simulations themselves in their own classes and for what they're trying to engage with their students. So this sampler, which is the one that links from Instep, actually has hidden behind it a data set right here. And in that data set, what it contains is it contains the raw data that this sampler is pulling from. So let me talk a little bit about how CODAP works and then a little bit about the context and how I created this. So first off, we're dealing with simulating a probability model, or sometimes people call these random experiments. So when we do that, common examples that we could think about in the classroom would be we roll a die and we see how many times it lands on one, or we flip a coin, or we pull a card from a deck. These are all examples of random experiments where we don't know what the outcome's going to be, and we're trying to get a sense of like what are the probabilities of these things occurring. We also have a pretty good sense from a theoretical standpoint what those would be as well. For example, rolling a die, each outcome is going to be 1/6, 1 out of 6, based on the fact that there's 6 different possible outcomes. When we start to deal with things in real life scenarios, though, often what we're relying on is some sort of sample of data or information we have, and then we're creating a model based on that. So in our case, what we're trying to model is the racial demographics of the population of the United States. So what that means is if I'm going to create a model, I need to first know, what are the proportions that I need to be able to represent? What are the possible outcomes? So the Census Bureau is a great source for this information. This is the same Census Bureau table that's linked from Instep. And what you can see is under race and Hispanic origin, we have actual percents of the population that fall under each identification. Now, one thing to note here is that the way that the census and the US government considers race is separate than Hispanic origin, or sometimes that's referred to as ethnicity in governmental forms. We're just trying to look at race initially. So parsing those two things out. So we're only paying attention to these initial 6 possible outcomes of racial identification that are the government mandated ones. There are, of course, a lot more diversity of racial identities that one could consider, but this is what the census considers. And then we have the percents for each of those. So I want to create a model that's going to mirror what I'm seeing here percentage wise. One of the easiest ways to do that is to basically think about, well, I want to make it so that, if I have this thing that I'm collecting from, and that's how CODAP is modeling it here, you could think of this as like the lottery. If you've ever watched them do like the pick six lottery or some sort of number picking, it's usually some sort of plexiglass box with a bunch of ping pong balls in it with different numbers on them, and the air blows beneath it, and then a ball pops out the side, and then that's how they pick the number randomly, right? So what we're trying to do is use that kind of image, that model, but in this case, what we're doing is the ping pong balls that are in there are the racial identities of everybody in the US, and we're trying to figure out if we keep drawing random samples about what proportion of my sample is going to end up having a certain racial identification. And so what I need is to figure out, well, how many ping pong balls do I need in there? And then how many of each need to have a particular outcome on them, again, to mirror the census. Now, part of this is just a level of precision. In this case, since the census is reporting to one decimal place on a percent, which again, a percent is out of 100. So really what we're trying to say is we want accuracy to the thousandths place. So 3 decimal places of accuracy with what we're doing to mirror these percentages that the Census Bureau is reporting. So a way that I can then create a model from that is to say, well, if I need accuracy to the thousandth place, let's make a model where I have 1,000 possible outcomes. And then how many am I drawing from each of these possible outcomes for that total population of 1,000? Well, in this case, what's 75.3% of 1,000 then? It's 753. Now, I don't want to sit here and type out the outcome white alone percent, or white alone, I should say, 753 times. So what I can do is I can use the affordances of technology to speed this process up a little bit. Now, for me, the easiest thing to do was to use Excel. I know how to use Excel. I know I can do fill down on it, and I can do it pretty quick. So I basically went in and put a label in here for what my variable is going to be. So that takes up one row. And then I need 753 rows that say white. Well, I can type it into one row, and then if I go to this bottom right-hand corner, I can click and drag down and fill down until I get to row number 754. Now it's 754 instead of 753 because remember that first row is just our label. So we had to add one to it. And then I can keep following this process. So now I have 754 rows filled out with white. I need 137 rows filled out with black or African American for my next category, and so on and so forth until I end up with a complete model here. Now, this I can then save. To save something to then use it in CODAP, you have to save it with a particular file extension. This is super common with any kind of data file. And the file extension we use when we go to File Save As is a CSV, comma delimited file. What that means, technically speaking, is it strips out all the proprietary formatting, and all you have is essentially the entries of each cell separated by a comma. And that way you can kind of move from program to program without having all the other like Excel kind of eccentricities involved with it as well. Once I save it to pull it into a data set, all I have to do is drag and drop from where the file is located. Now, to create a new CODAP workspace, if I go to the CODAP website here, I can just go to the top right-hand corner and hit Launch CODAP. That's going to create my space. I'm just going to start with a whole new document here. I need my data to be able to create my sampler. So the first thing I'm going to do is actually this data set that I just created that's going to replicate the US population in terms of racial identities. I want to get that in there first. And so I pull up my downloads file, which is just happens to be where I saved mine. You can save yours wherever you want to. There's my file right there. It's a .csv. And I'm just going to drag and drop that over here. And voila, it has populated my data into CODAP. I don't have to do anything more with it. Now I could sit here and I could create like a graph to look at what this thing is, but I actually already know what it is because I saw what the table was showing me. And so I don't really need this right now per se. Now you want to see like how did I get to this part here where I have the nice little sampler and then the description and everything set up. So that's the next thing I'm going to show you. So I have data now. To create a sampler, I go to this plugins button up here that looks like a old school appliance cord. And sampler is actually the first option here. There's all sorts of fun stuff you can play with in here, but we're just going to focus on the sampler. So when I click on the sampler, it defaults to this mixer where it's just got three possible outcomes, or actually two, one of which is repeated twice. Now, I could sit here and actually I could clear this and play with this and I can add more of these things and I can modify this one however I want. There's a spinner version too. But the easiest way to do these larger kind of models that are really precise like what I showed you is the collector. So the collector specifically draws from the data set available, and I can see it linked down here too. That's the actual name of the file, and so it's pulled it in here. So now I have my sampler. A behind the scenes probability perspective with this is what this is doing is it is sampling with replacement, which means every time you pull one out, you put it back in, which means the probabilities of pulling anything stay the same, stay fixed. So each draw is independent, which is important for us to consider in terms of the population of the US being as large as it is. So from here then, now I'm ready to go. I have the sampler set up. I can change the number of items I want in here. I can change how many samples that I want. The only difference between this and what I have linked on the CODAP website is I also have some text to explain what's happening here. And that's the last thing that if you wanted to add that in, I'm just going to copy and paste because I've already typed it once and I don't want to type it again. But this text button here will create a text box. And this is great for when you're working with students and you want to give them just, some basic instructions to get them going. Or maybe there's some particular information that they might reference back to frequently in the investigation that they're doing. It's just helpful to have it in one of these text boxes that we can go to right here. And now you can see this is exactly what we start with in the investigation. So there's an example of how you can create a simulation yourself based on different data. Now, if you collected some sample and have the raw data already, you don't even have to create it like I did. You can actually just download that data into here, and then you can sample from that data set itself. In my case, it's a little more complicated because all I had was these summary statistics here, and so I had to create kind of raw data, so to speak, that's going to act as my model to replicate this. All right. Well, hopefully you find this helpful and enjoy playing with CODAP.